In this video, we're going to take a look at lambda functions in Python. These are very commonly used in the Python programming language, and they are basically anonymous functions that are designed for single expression use cases. So small, logically concise pieces of code that you want to wrap in a function. Oftentimes you'll find that lambda functions are the best way to do that, and also you might use lambda functions inline as you do with the sorted function here, so they can be used as functional arguments to other functions. Now we're going to cover all of that later on in the tutorial, but it's important also to note that lambda functions can have arguments and they can return values just like normal functions in Python, but they have this different syntax here. There's no def keyword. They can be used in line with the lambda keyword and they can take arguments. So let's cover all of that in this video and get started just now. All of the code in this video is available on GitHub. The link is in the description, and there's an associated blog post on the 𝗦𝗶𝗹 website that you can check out as well. Now let's get started. We're going to first of all look at a famous equation, E equals mc squared. This is an equation from Albert Einstein, and we're going to use that equation. I'm going to define a lambda function to calculate the E parameter in that equation. So I'm going to paste some text into this Jupyter notebook, and this is just a bit of background. You can read through this on the GitHub. Basically this is E equals mc squared, and it's an equation that ties the energy to the mass of an object. And there is a C parameter, the speed of light, which is a constant, and we square that in this equation. So what we're going to do is write a lambda function that will take in the mass of an object, and it will then calculate the E from that mass. So let's first of all write this as a normal Python function to compare the differences. So we'll start by defining the C parameter. This is a constant and it's equal to 300 million. And then we can define a function which we'll call energy. And that takes in a parameter mass, which is a floating point number. We're using Python's type hinting, which is available in Python 3. And that will return another float representing the energy. So what we do is we return that mass, that's the m part of the equation, and we're multiplying that by c squared. So just c squared is that syntax, and that will give us the resting energy of the object. So now let's do a few calculations there. We're going to say that we've got a mass of 1 kilogram, and to calculate the energy we will just call the energy with that value, and that will give us an energy back. And we get back this very large number here, which is showing us that 1 kilogram of mass actually has an awful lot of energy. So that's quite interesting. But what we're wanting to do now is redefine this function as a lambda function in Python. So let's get a new cell on the go, and we're going to say energy equals, and we'll use the lambda keyword, and we still accept the mass parameter. So that is, the parameters are to the left of this colon here, and then the body of the function, the body of the lambda, is to the right of that colon. So we're only accepting one parameter, and we're going to return mass times c squared. So this is an alternative way of defining the function, and if we pass the m value to the energy, we get the same number as we got above, but we've got a different way of defining the function. So the way to define a lambda like this, you take the lambda keyword, you take the parameter list on the left of a colon, and the body of the function is on the right. And as I said in the introduction, the body should be small, it should be concise. Otherwise you want to use a normal function like this where you can have multiple lines and expressions. So now I'm going to paste in some dummy values here just to show you some interesting figures. Now the Earth's mass is this large number, human mass is roughly 70 kilograms, and the mass of an American cent is 0.0025. And if we plug those values into the energy lambda function, we get back the value for the resting energy. Very large numbers all round. So in the next section of this video, we're going to take a look at some corporation tax calculations. Now, corporation tax is one of these things that you have to pay if you own a company. And I'm just going to paste this text in here. Now in the UK, where I'm based, the corporation tax is set at 19% of a company's profits. So what we want to do here is write a lambda function that takes as its arguments a company's income and its expenses. Then we want to determine the profits that the company makes, and then we can multiply by the corporation tax rate to find out how much they should pay. And then we can compare that UK rate of 19% to Brazil, which is a very high corporation tax percentage, and also the Cayman Islands, which actually doesn't have such a thing as corporation tax, which is quite interesting if you own a company. So let's get started with this. We're going to define a UK corporation tax rate of 19%, so it's 0.19. And then what we're going to do is define a lambda function called corp tax, and it's going to be a lambda, and it's going to take in three parameters. First is a company income, the second is company expenses, and the third is a rate. And from those parameters, what we're going to do is return the maximum of the income minus the expenses. That gives us the profit margin. We multiply that by the rate, and we take the max of that and 0, because if the income minus the expenses is a negative number, in other words, if the company has spent more than they brought in over the year, then that will be negative, and we can't have a negative rate of corporation tax because that would mean that the government pays the company. And instead of that, we're going to say if a company makes no profit, which is essentially what that's saying, if it makes no profit, then we will simply return 0 for the corporation tax. Otherwise, if it does make a profit, the income will be more than the expenses, and we take that profit and multiply it by the corporation tax rate. So that gives us the lambda function, which we can then test out. I'm going to print some dummy values in here, and what we get here is, like, let's walk through these three scenarios. If we have a company making £20,000 and they have £5,000 of expenses, that means they will pay £2,850 in corporation tax. If a company pays 20,000, or rather they have 20,000 income and they spend 22,000, that means they've made a loss, therefore they don't pay any corporation tax. And we've got a larger value here, a company paying 9.2 million in corporation tax from those figures there. So if you look on the blog post, you can see what this is doing in greater detail, and you can look at the Brazil comparison and the Cayman Islands comparison. But this is just showing you that you can take multiple parameters to a lambda function, and then you can have an expression that's as complicated as you want, but it has to be a single expression in Python as the function body. So now we're going to finally talk about using lambdas as inline parameters to other functions in the next section of this video. And we're going to work with movie directors. So let's paste in some text here and we'll work with that. Now we've got lambda functions as parameters here as a headline. What that means is that you can pass lambda expressions inline to other functions such as sorted and max and min in Python, and these can then be evaluated and used by those functions to determine some sort of behavior. So let's get started and see an example of that within the next code block. I'm going to define a list of directors within this cell. Now we've got Kubrick, Scorsese, Lynch and Wells, some classic directors, and what we want to do is, let's say we want to sort these, it's a list of dictionaries, we want to sort them by the age from the youngest director to the oldest. So let's say we're using the sorted function, and we'll pass in the directors, and what we need is a lambda function to determine the key, because there is no natural order for a dictionary. We need to say, well, we want to use the age field as our key. So we take in each director within the lambda function as a parameter, and what we can do is we can index into the age key, and then that will sort by the age values. And what we get returned here is each dictionary sorted by the age. We get the youngest first, and by the way, these are made up ages. David Lynch is not 30, and we can get from youngest to oldest using the sorted function. So you can see how we use the lambda function here to determine the behavior of the sorted expression. If we changed the key to name, then it would sort in alphabetical order by the name, and we get Kubrick first because it's the first alphabetically. And finally, we're going to show how to get the oldest and youngest directors using max and min functions. So let's get the oldest. We pass in the list of directors, and the key this time is going to be exactly the same as we originally defined for the sorted function. It will take in a director and it will index into the age I say index, it will look at the age key to determine the oldest director, and we get 𝗰𝗹 as the oldest. Similarly, to get the youngest director, we just need to substitute the max function for the min function. Again, the min function takes a key parameter which you can set to this lambda expression, and then that will give you the youngest, which in this case is David Lynch. So that's all for this video. Thanks for watching. If you enjoyed this content, please check out the blog post where we go into more detail. All the code is also available on GitHub if you want to check that out, with a bit more detail, some more text to explain some of the work that we're doing here. And if you have any questions, please reach out on Twitter. But thank you for watching. Please like the video if you've enjoyed this, and I will see you again soon.